Panel is about measuring security. You know that one of the hot topics that we've had in the last 5 years or so, it's about antivirus testing. Antivirus testing has changed a lot because the threat landscape has been changing quite dramatically for since 2005 or so. And therefore, the testing has had to move, or the tendency is to be moving from the old static testing. What we have here is 4 members of the testing people. So we have Vikram Fatak, right, from NSS Labs. We have Ferenc Leitold from Vespro. That's our Hungarian tester. We have Alice Decker from the Anti-Malware Testing Standards Organization. That's an organization that aims to create better testing procedures. And we have Peter Stelzhammer from AVComparatives. So we have a good selection of people who know a lot about testing, and hopefully they will enlighten us how they're changing their methods, if they're changing, and how the procedures are. So we intended this as an audience-driven discussion. So feel free at any point, just shoot us any question you have about it. I will leave first a few minutes, each one of them, just to tell their credentials, what they are, where they're coming from, what they think about this, and then after that we'll go into the discussion. I'll try to steer it with some questions, but by all means, if you have any, just shoot it. So first, I'll relinquish the floor to Vic. Is that okay if I call you Vic? Okay. So Vic will tell us something.
Thank you. So, Vic Fatak, I'm with NSS Labs, Chief Technology Officer. We've been doing testing. Well, the company's been doing testing since '91. Primarily started off with intrusion prevention, firewalls, and things like that in the network side. A couple of years ago, we switched to doing, or added the host-based products, and we focused on live testing as our goal, because we looked at the issues that David talked about in the changing threat landscape, and we realized that the host testing wasn't reflecting that. It was sort of the used standard certification stamp. The one difference between us and I think pretty much I don't know how the Hungarian folks do, but we're the only ones. Now Peter does it a little bit differently too, but the short of it is that we don't take money from vendors. Okay, so we do our testing and we charge enterprises to read the reports, which is the biggest difference, because that way my alignment from what my goal is perspective is to make sure that my readers have the most valuable information. It's not to create controversy. It's not to give somebody a pat on the back. It's just to tell them the facts so they can figure out what's the best for them and what do they do. So it's a little bit different from the traditional certification where vendors pay to be certified, and it's valuable, and there's reasons for that. We do things a little bit differently because, again, we provide more of a technical analyst role versus, I'll say, a minimum certification. So I'm sure there's going to be a lot of questions, but that's sort of the gist of what we do. So I'll hand it over to you.
May I ask that?
Oh, the presentation. Oh, okay.
Thanks. Get more comfortable.
That's no problem. So I am Ferenc Leitold from Vespro Ltd. And some problems.
Can you just drag it over there? Can you just drag it?
Yes, I haven't got any.
It's behind your nose. Mouse is there.
Yes, I know, but this is not the same. So I set it and I go to where it is.
Okay. So, good morning. My name is Alice Decker, and I am employee of Trend Micro, but I represent this company in anti-malware testing standard organization. This organization was set up in 2008, and it's a community of antivirus vendors, testers, and magazine representatives. And the charter is, so what we want to achieve is to bring up and support new methodologies which are able to reflect either the actual landscape and also the capabilities of the products in order to really bring up protection for the users. As we had, so in the history, it is so the landscape changes itself, so that in the 90s the malwares were brought to a system, let's say like that, through boot sector on floppy disks. So and then afterward we had propagation, so the threat delivery was made through email. That was in the, around 2000. To that time also we had macroviruses, and so the whole threat landscape evolved. However, so until 2005 we could say that the number of the threats is more or less known. So like looking at the number of signatures we had, we could say, okay, so the world has around 150,000 threats. So nowadays, so within 5 to 6 years, so the number of these threats evolved from those 150,000 unique threats to more than 5 million. So that we think that there is a strategy of the cybercriminals in order to, let's say, kill the AV industry and everything it's around. So that what the antivirus vendors did was to change their technologies in order to fight this high number of threats, and also, so in the same time, to be able to give up a higher protection to the users. And in the same time, the tests, well, let's say, tried to evolve, tried to come up. However, we had massive problems in the sense that the tests keep staying with simple scanning over a collection of files, and just at the last time some tester organizations attempted to change this, and one of the pioneers is NSS Labs from the US, and also AVComparatives and other guys. Which is, so from AMTS perspective, this is a great thing, and we hope that this will keep moving so that the user finally have an idea or can be led into how product fits best to his environment. Okay, thank you.
Thanks. So, I am Ferenc Leitold, and I am dealing with anti-malware testing since 2002, and I would like to start with a little history of antivirus softwares and reflecting to the main point and difficulties of testing. And of course the difficulties of anti-malware testing nowadays. And last, I would like to say some words about our checkpoint testing and that we would like to do to solve these problems. So, a very long time ago, it was 22 years ago when I have met with my first virus, and it was this cascade. It was in 1988. Some months later, I think it was in January 1989, I have received an antivirus program called scam.exe. It is a very old version of the McAfee product, and it was able to detect 18 viruses. It used only on-demand scanning. It was just for detection. For disinfection, there was another program, and it can be run under DOS operating system only. So I think in this case, it was a very, very easy test to test this program. So a very limited number of threads, a very limited number of operating system environments, and so on. For 2000, the testing tasks became more difficult, and for nowadays they became more and more difficult. What are the main problems now? In my opinion, one of the main problems is the detection of 10 million of malware. So an anti-malware product has to deal not only with 18 viruses, but a very big number of malware or of other threats. Not only on-demand scanning are built-in security product today. There are other protection on access to active and so on. Not just detection, but also, of course, disinfection also. And there are a lot of operating systems in many, many environments. So in this case, anti-malware products are, I think, one of the most complicated software type. Because anti-malware products has to cooperate with 10 millions of other program code. So they have to detect them, they have to disinfect, they have to block, and so on. So the antivirus world has been changed, and as you can see, hackers are everywhere. So what are the main difficulties? So the first part is from the threats. So the big number of samples, big number of threats exist, and there are new techniques. For example, drive-by load. It means that not only samples should be tested against antiviruses, but URLs which can be changed in that time as well. Security products use newer and newer techniques. For example, the cloud technology. In the last years, security products are implemented protection which can cooperate with the vendors' computers at their place, and this is a real-time communication, and it means that testing security products cannot be repeated in every case. There are very frequent updates of antimalware products. There are antivirus where there are updates in every 5 or 6 minutes. So there are new methods which need proactive testing as well. So what is our purpose in this world? So testing all versions are impossible because they are released very frequently. So we would like to execute tests as frequently as possible. So for this purpose, automatic methods should be developed, and of course a very high number of computers should be used. The main purpose is to provide reliable, correct, and exact information, mainly about the effectiveness and performance of anti-malware products. Of course, these two main things, this effectiveness and performance, should be tested in a balanced way, and this is one of the main principles of NTSO. So methodology is an automatic procedure which is automatically update anti-malware products, and if there was a new version, then we execute a predefined test, and after that we will publish the results on the net as soon as possible. In this, it means that we would like to test not the past, but we would like to test the present as it is possible. So, for this purpose, a lot of computers should be used, and this is for infrastructure for testing. There are controller computers, archivers, and so on. There are a special malware proxy server which is designed and built for executing proactive testing. What is the problem with proactive testing? Anti-malware products use cloud technology, so traffic should be alert from the clients, the tester computers, and between the tester computers and the vendors' servers. And on the other hand, malware would like to use cloud technology, so they would like to download another part of its code. So, but we would like to provide exactly the same environment for different anti-malware solution, and of course we would like to protect the world, so we don't like to spread the malware from our network. So for this purpose we designed this special malware proxy server, and we have set firewall rule which enables the traffic for cloud technology used for anti-malware, but it redirects the traffic from malware and to the proxy server, and in this situation we can provide the same bit row for each anti-malware product when it would like to download something from the internet. So, as I mentioned, we are executing tests for testing effectiveness and for testing performance as well. The first part is the malware knowledge part. It is for detection, disinfection. It includes on-demand scanning, on-access scanning, proactive scanning, and so on. And the other, but not so important part of this knowledge test is container checking capabilities. So we would like to test that what kind of archive email clients data files can be checked by the anti-malware. And for the other purpose, the speed tests are relative to on-demand, on-access, and boot time, of course. And in my opinion, both parts, the green part and the blue part, should be tested together using the same settings in each, in the case of every anti-malware. And of course, we are planning to test functionality, stability, and so on. So at this moment we are working to enable these testing possibilities, testing features on the internet. At this moment we have a working frame system which can test and update and execute these tasks, and now we are testing it, and I think it will be ready and it will be published from the first part of the next year. That's all.
Monitor. Thank you. Schon mal in Hand?
Peter Stelzhammer from AVComparatives. First of all, please apologize my bad English. I'm from Austria, and it's not easy to speak German as an Austrian too, because we have a totally other slang, so it's a little bit more difficult to speak English. We are dealing in the anti-malware testing since more than 10 years. I am working in the computer industry since 1981, so it's a very long time. I've started on mainframes where malware signatures was delivered on 5-inch floppies, so that's now not even more possible because there are so many signatures. We are AVComparatives is an Austrian non-profit organization, and we always stay independent. So we are doing our tests totally independent, and we do not belong to any vendor. We are a founding member of EMTSO, of the Anti-Malware Testing Standard Organization. And even if we are a not-for-profit organization, we need some money. So we do commercial consulting of large business and worldwide concerns, and of government and large business. This is the way we earn our money, and a part of this we are refunding to the AVComparatives for testing. Now on this topic today, it's about changes in malware testing. It's getting more and more difficult. If you look back 3 or 4 years before, or just the last year, it was very common to test with on-demand testing. Just to right-click and look what is the detection rate of an antivirus. It was totally replicable, and it was very, very easy to test. And nowadays, like Ferenc told, it's getting more and more hard to test it. And we have also, like all others, like NSS labs or other test labs, done a new methodology. We have done a new test of the whole product dynamic testing in August. And I have the test with me, it's done. We are not releasing it next year or in 2 weeks. We are releasing it to the evening. I have it with me, and we can talk about this test just right here now in this auditory. A very important thing is that the tests now are not more replicable. It's not so easy to do it because you're working with products which have their services in the cloud. You cannot test. You can do a test today in the morning, and today in the evening you will get a different result because the vendor has updated their cloud. Or if you are researching for malicious URLs, you are researching for them and you find them right now, and in 10 minutes they disappear. So you need more and more, and really more URLs to test. It's not possible to give statistics relevant or prevalent tests without testing less than 100 or 200 URLs. If you test with 50, 60 URLs, and I have a statistic here, we can talk about this later, you will get results which are not statistically correct. So you have to test 500 to 1,000 URLs a month, or better, you have to test 100,000 URLs. But this is not possible. So we have to test as many as we can. And in our new testing methodology, we have a new system where we can test as many as we want. It depends only on the hardware. So now we are a not-for-profit organization. We're working now with 400 servers in our lab. It's crazy expensive. So we have to do the testing on as many machines with less money as we can. And we try to do this. And as this is an introduction, I will stop now and give to David back, and let's start the discussion.
Good. Can I have one of the Thank you, guys. So I'd like to kick off this discussion and veer it towards the topic that it already came up about web malware. Specifically, malware has been using the web extensively, really extensively, to download, to update themselves, and to communicate with command and control centers. And that introduces a new thing into the testing environments, which is the internet. Now, your testing environments need the internet without any exception. What implications does that have for the tests in your view, and how does that affect your testing, or has affected your testing? Will we do it by this order? So first Vic, then Ferenc, then Alice, and then Peter. Is that okay?
Yeah. So, I guess a couple of things when you start talking about the internet. It's being able to ensure that when you are testing malware, especially the execution part, that it doesn't get out. So there's tends to be certain types of rules you have to have in watching what's going on, that you want to allow command and control to go out so that you can see if it's, for example, hooked up to a bot, what's going on. But if something starts creating, for example, a major attack, that you're able to see that also from a threshold perspective. So there's that. Also, one of the things we found, and I'm sure Trend Micro and others have found this as well, is that if you become too active, the criminals are correlating the data. So, for example, we have to rotate our IP addresses all the time. We have to actually hide ourselves within consumer IPs. If I use the same IP address 2 times in the same hour, the second time it'll be dead in a lot of cases. So, and there's actually some viruses or some web-based bots and things like that that are out there that specifically look to see if you come from the same IP address within an hour, then the code says then dish up a 404 or something. So there's additional complexities as soon as you start talking about web. I think that the biggest one again becomes, how do you hide yourselves amongst sort of all the other clients that are out there, all the consumers that are out there, not give yourself static IPs and things like that, yet have the firewalls, yet have all the proxies and the protection you need, right? So that's one of the challenges. But again, we came from a little bit different perspective than the traditional AV tester. We've been dealing with internet-based things for a little bit longer. We've been testing network IPSs and other devices that were network-based. So it was we weren't doing the on-demand click. That wasn't our expectation coming into it. So for us, it was as a newcomer into the AV testing area, it was probably not as hard for us to change as it would be for some folks who've been doing things a certain way for a long time.
So the main implication of the new threats, wares, and so on, I think these new malware types radically changed the testing, and the first, the number of the new malware have changed, and on the other hand, in my opinion, I think it is very difficult to select a relevant set for testing, because URLs are not for many time exist, and it means that, for example, months and later, the malware cannot be accessed. And in this case, the test is not cannot be reproducible, and it means that in a month later, that malware, that threat is not relevant. So I think it means that the testers have to change the methodologies according to this.
So one of the fundamental testing principles in MTSO is that the test may not endanger public. So this initially this sentence would lead to the idea that a test made shouldn't be done with internet connection. But on the other side, the technologies and the solutions provided by the vendors need and ask for internet connection, and also, so the threat delivery nowadays is more than 90% made by web. So that's why we agree that internet connection it's needed for testing, but in the same way we still ask that a test may not endanger public. What is the effect of that? One of them would be that in case a threat is spreading to a vulnerability, like we had the overwhelm, so that one shouldn't be used for any kind of test. Why? Because that one, it's able to spread over the world, and if such a worm invades a testing lab, it would endanger public.
What we have seen, what is changing. Former days we could say a file is malicious, a file is clean, or it is a false positive. It was very clear, and now we are getting results in our tests. It could be suspicious. The user is sometimes shifted, the decision is sometimes shifted to the user, but my grandma doesn't know what to do if there is standing, file could be suspicious, or this file hasn't been downloaded very often. You are one of the first users which is downloading this file. Do you want it to execute in any way? A child will execute it because it is not thinking about is it bad or not bad. And this is one of the problems we are solving in our analyzing of the results we're getting. We have to interpret the results in the right way. So we have to define a user. Is it a grandma user which is blocking everything, or it's a gamer who is accepting everything to get his serials or his key generators or anything else? So it's very hard for the user because the decision is shifted to them. About the replicable, an on-demand test could be repeated in any time. You can freeze the machine with the signatures and you can repeat it. And now vendors are using host-based methodologies with cloud-based services or URL blocking or DNS blocking, and the response is changing every second. Another problem Vic has spoken about is the thing with the IP. We are using in our lab 32 different IP addresses which are changed every 8 hours, because the guys who are doing the malicious things, they are not stupid. They know exactly what they want, and they know exactly how to infect the workstation. So if you're going to a malicious URL, it could happen that if you come back with the same IP address, you will not get delivered with the malicious code. You will see a very pretty site, or you have to go through a referrer to the site, because if you go with a direct link to the malicious code, you will see a HDXS driven site which displays a totally different thing. So you have to replay the way the user is coming to the URL. It's not done that you point directly to an exe file. You have to go to an exploit or to a drive-by download, and you have to go the right way. You have to search in Google, you have to click on the referrer site, and then you have to go to the right site. And also it could happen that as we are sitting in Austria, you might think we are using Austrian IP addresses. No, we have agreements with providers so that we get IP addresses geolocated in the UK, geolocated in the United States, or from Italy, or from Germany, or from Asia. Because the delivery of the malicious code is different if you're going from Austrian or from a UK IP address. You get different malicious code. They're doing language selection, that you're going rogue AV with German language or rogue AV with English language. It depends on the IP address you're coming from. And that makes it so much harder to test. And you need really, really much hardware. Nowadays, 300 or 400 servers, we cannot count them. You need crawlers, you need honeypots all over the world. If we are looking for malicious code with our crawler only in Austria or Germany, it's too less. We have to look for it all over the world. We have about 60 honeypots. Also here in Spain, we have 2 honeypots. And you need for each honeypot agreements with providers. Because if you have a honeypot and he's collecting malware, the provider will cut off your connection if he sees that you are dealing with malware. So you need an agreement, and that makes it really hard for us, because it's more administrative things to do than testing. It's really hard. I'm thinking back to David.
Is there any question on the web threads and how they affect testing? Because I already have questions on my own. So, when they were speaking, for instance, I was thinking, if you guys get a URL start testing products with a URL, and in the middle of testing, it becomes dead. Just gets down, knock down the whole server, do you count it for the rest of the product? Do you invalidate that URL and you stop testing? Then it's a situation that may arise. I don't know if it does very often, but how do you consider that URL? Do you take it down from the test? Do you continue testing and you count it for the ones who did detect it up to that point? Just a question.
So I'll give a third option, which is that everybody goes to the same URL at the same time. So, and we also test over time. So we'll test over a period of 10 days or 15 days or something like that. Now, almost invariably, almost every single URL that starts off in the test, by the end of the test, it's not there anymore. So we count them as long as they live. So we actually measure how long the URLs are taking, and we measure how long it takes for the blocking mechanism in products to work. So we call our time to block. So some folks may take 2 hours and some may take 72 hours, and that's how we can measure. So it's the same. So that timing issue is measured.
Okay, but all requests are done at the same time, right?
All requests are at the same time for the same URL. Exactly.
So we have a little bit other solution for this. We first download everything from the malicious site, store it in the proxy server or proxy, and we provide the same bitfall for each anti-malware. And it means that we can replicate this test with the same content of that site. And of course, it means, on the other hand, that we are sure that each anti-malware receives the same bitfall. On the other hand, that we can store not only the state of the malicious website in a time, but in every time it has been changed. I think the main problem is what it was mentioned, that the testers has a network, the testers has an IP address, and we have known malware which has anti-malware tricks inside it. What can we do if there will be a malware which has an anti-malware tester tricks in it, so it excludes the IP address of testers? Then we can't do anything. So we would have to ask for another IP address, and it would be a problem in the future.
We are changing the IP address automatically every 8 hours, so it doesn't happen. We do the same way like NSS Labs. We are testing one URL at the exact same time. It's just a time shift of about 5 to 10 seconds, not more. And we are not using a proxy. We are using a direct connection to internet, because we have seen that some vendors, if you're using a proxy and also if you route the vendor's cloud-based access, so not over the proxy, get different results. So we are not using any proxy, but we have 5 workstations running which are doing the same through a proxy, so that we have a proxy to replay everything. Another thing is, if you are researching for an URL and you are you're testing the URL, you can reach the URL and there's still a site on it, but it's not anymore malicious since 10 minutes before. So we have to check every case. Do we reserve a site which we're thinking on it's malicious, but it's not longer malicious because the malicious code has disappeared? So we have an automation system which is checking for file changes, register changes, and anything else that we can prove our reports, that we can prove the test case. It's very important that you can prove. And I think about half a year ago everybody said, no, it's not possible to prove the test because it's cloud-based or you cannot store it. But in this way, and in our test we have seen this, we have delivered several URLs which are malicious to vendors, and they told us, oh no, they are not malicious, you have to remove them from the report. And we can prove them. It is malicious. Why are you telling us that it's not malicious? Here is the proof. Here is the file which was dropped on the desktop. Here are the file changes. Here are the register changes. That's a smaller problem if you can prove it. But every vendor tries to deal the game of the testers. Every vendor tries to deal it. And so something we are disclosing from our test to the vendors that they are not able to know what we are doing in the exact way. Because if we do this, they will deal the test.
I have more. Speaking about the URLs, we have changed, the environment has changed in a way that files, which used to be the traditional bad thing to look for, now they have changed to not only looking for files, but also looking for URLs. URLs are as bad as a bad file. So you're looking for both. You're testing both a bad file and a bad URL. Does that change the, how does that change the results of tests? You have to do two different test sets for files and for URLs. You consider them the same, just as malicious? Are they different test beds that you draw stats from differently?
Well, so for us, we test it all the way through. So we start with the URL, we'll click on the URL, something downloads, and then we execute the file. Or if it's able to download, sometimes it's blocked, in which case there's nothing to execute, right? But that way we can go from sort of cradle to grave, from beginning to end, at any given point in time, and we can know what the different block rates are. One of the challenges, and I think Peter alluded to this, is that, and I've talked about this before in some marketing, or not marketing, so some of our marketing and PR material may be talking about this, that the threat landscape has changed. It used to be that the only thing you would see would be viruses that would grow exponentially. I give it to you, you give it to people you know, they give it, and so on. So in theory, if you were 2 weeks later and an AV signature came out, then that was okay because you're still protecting millions of people and only maybe 10,000 people got hit. Right? You hadn't hit that inflection point where massively increases, or the virus massively increases in rate. Well, with the web, what we're seeing now is that it's campaigns. We're seeing things going through advertising networks. We're seeing things going through social networking sites, Facebook, Twitter, and so on, right? So it's a complete shift. Whereas instead of the attack being back-end loaded, which is what a traditional virus is, it's now front-end loaded, Trojans and keyloggers and things like that, right? So it's a different type of a threat. So if you wait to measure, if you wait a day to measure, it can change and skew the results tremendously, because most people are being infected by this web-based attacks within the first 48 hours. So if you wait 24 hours, half the people that were going to get infected are now infected, and you haven't been able to measure that. So as a tester, freshness becomes really, really important. You didn't really ask that, but that was sort of, I think you're right. And I think Peters has the same approach with this. So what we're seeing in our results is very different from traditional AV testing, where, let's say, you've got your wild list, which traditionally is about 60 to 90 days out. So the way it works, for those of you who don't know, is someone says, I found a piece of malware. They then have to get somebody else in a different organization to concur. So you have two independent researchers say, yes, that's right. It then gets put into the wild list. Now this process can take, again, 60 to 90 days. But by then, if you're talking about a web threat, it's not only long gone, I mean, it's forgotten about a long time ago. I guess so there's this whole approach, I guess, in the whole thought process, that we become, to a large degree as testers, researchers, because we have to be able to keep up. And the whole idea of traditional testing was you can have a test harness, you make your upfront investment, and then run it for 5 years and reap the rewards. Well, testing has become a lot more expensive because, again, it's front-loaded in research. And research is ongoing and continuous. So I'll hand this off, but I know probably... Okay.
So I think that one of the most important things for testers to prove that every tested sample is malicious. And the main purpose of it, in my opinion, is that there are anti-malware products that can detect or block malware if it has execute some activities. And if there is a malware which is not execute some malicious activity, then it may not be blocked by a specific anti-malware product. So thus, suites, malwares, it doesn't matter that it is files or URLs, it should be proved that they are malicious. I think there are two ways for proving them. The first, we have to check all of tested samples that they are malicious or not. And we can check URLs and files as well. And it can be done easily if the tester would like to use, for example, 1,000 or 10,000 of samples. But if 1,000,000 of samples should be used, then it is impossible because there isn't any such computing capacity. So in this case, statistic methods can be used for this purpose, and for example, not only for all of samples should be tested, but randomly selected samples can be checked. And of course, in this case, using the probability analysis, error margin can be calculated for this sample set as well. So.
But yeah, I agree with you guys. However, I hear from you about some types of samples that are tested in your labs. However, my opinion is that the raw scores of a test are mainly irrelevant without putting the how was tested and the scope, so the why. So why a test is done, so what a test wants to highlight, and also the how is very important. I think that we have also talked about the how, where as you described the way how the lab is set up and the way how was tested, but it is pretty important from my perspective, the scope. So what is the scope of a test?
Yeah, that's the true thing, the scope of the test. Let me switch to our whole product test report. There we can have a look at it on the statistical page, where we can show the other results. We're coming to them later of the first whole product test. Okay. It's very important to test as much samples as you can, because if you can see on the graph, if you're testing only 10 samples, the range is between 65 and 90%. It depends on the product. So you have a range of 20% which could be not correct. And if you're testing more and more samples, if you're testing 100 samples, the error rate is about 10%, and if you're testing about 1,000 samples, the error rate goes down to about 5%. Now we are testing about, in this test we have tested 308 samples, so we think the error margin is around 7%. 7% is even a large scale, but We are now trying to do more samples in the next months, and we're doing it continuously. We're testing every month, and we're increasing our samples every month, so that we go to an error margin of 2 or 3%, and this is an error margin, we have to live with it. We cannot avoid this. That it is as it is. You cannot do anything against it, because we need to test one sample about 5-6 minutes, because it's also very important that every test is done, in this case, on real machines. We are not using any VMware or any other hypervisor things. We're doing it all on real machines. So you have to re-image the machine, you have to download, you have to update every case. And that is doing very, very time consumption. We need about 6 minutes, 7 minutes, differs on the workstation, to do one test case. I think you guys know all the virus total. You can submit a sample or a hash to virus total. We are doing exactly the same, but we are doing it with an URL. We can submit an URL to a web interface, and after it's submitted, our whole lab is powered on. It's for saving energy too, so that if there is no URL for testing, the lab is powered off. And if any one of our researchers is submitting an URL, the lab gets powered on, does the test for this one URL, and after 20 minutes the lab is powered off again. In this time, if there's another URL again, it stays powered on and does the test again. But if there is a pause of more than 20 minutes, the lab gets powered off, so we can save in energy. We are now paying about 2,200 euro only for power in the lab, so it's very important to save energy, not only for the environment, also for the total cost of ownership.
I have a question with respect to how.
You want the microphone?
No, that's fine. Okay. How do you approach a role there? As in, that's the software which looks authentic, and most of the time you must have come across, let's say, antivirus software, or which says that it's antivirus software, whereas it's actually malware. So how do you approach that? And second thing, what about malware that comes through the smartphones and iPhones? What's the strategy for addressing both of these?
So, I'll answer that in one moment. I want to say one thing real quick, which is when Peter talks about, let's say, a 3 or 4% margin of error, he's not talking about the samples being bad. He's talking about the skew of the samples in one way or the other, that it's heavily weighted towards Trojans versus keyloggers, or something like that, right? I mean, it's not that there's a bad sample in the set.
It's not about the samples.
Exactly.
It's only the error margin of the test.
Exactly. So it's will somebody's score be a little bit higher, a little bit lower, given a different sample set? Okay. So now to your question about how do the fake AV and so on. So our approach, I can't speak for them, but our approach is to include those in our test. I mean, we're actively going and have, as Peter does, I think probably as Fenza does, we have active honeypots and things like that. So we actively have people manning them, browsing the web, doing social networking, doing Twitter, things like that, so that we can be targeted. I mean, these are real people sitting behind real PCs. So from our perspective, once we have it, it gets included. And now in terms of the smartphones, we're starting to do some testing in that area. It's quite interesting because from our perspective, there tends to be more exploit than traditional malware. And I personally think that the Android market is going to be like Windows 95 all over again. So if you're in the AV industry and you want to go make some money, figure out a way to protect Android, because it's a petri dish. And it will be, because the way it's a very open system, and it's up to every single handset manufacturer how they compile it and what they're doing with it. So it's not only just Windows 95. Imagine if Windows 95 was different on a Dell and different on an IBM or different on an HP. That's the reality of the handset world. And furthermore, once you have your handset manufacturer that has their Android, now it has to be specified for a specific carrier. And so again, you have another derivation. So if you can imagine imagine, with all those different forks in code, people take a lot of shortcuts to find the easiest and most common ways of doing things, which tends to be, where the exploits can occur and where the viruses and whatnot can take hold. So we're doing actually a fair amount of research in that area, and I can't say more about it right now, but we are doing research in that area.
Want to respond also to that question?
Yeah, I would like to point out, so if going from the word to the scope, so if a test is made and published and the test says that rogue AV have been tested, then this is a very important point, because it can be, so it does not reflect the whole landscape. So that's why the quality of the samples used is very important in the results. Maybe you have seen results where a product scores the best, and other test results where the same product scores bad. So there's constantly the question, why does it happen? So, and the first answer would be, okay, maybe the sample set used does represent just a portion of the whole landscape, or the methodology is different than the methodology used in the other report.
Yes, that's true. There are 2 points, the rogue AV and the mobile security. At the mobile security, we have released just 1 week before our mobile security report, and it's the same. Android is not protected. It's a short answer. There are only less products which are protecting Android. Android is an open project, and I think it will be in future one of the platforms with the most attacks will happen. It's easy to crack, to say it in a short way. And in our mobile security report, we have found major bugs in products which are doing mobile security. So if you are going to buy a product for your mobile phone, and you should buy a product for your mobile phone, it's not about the malware, it's about anti-theft protection. Your mobile phone could be stolen, your data is on it, and everybody can read your data. That's the problem. The malicious code is not the problem. Go to your vendor, to your provider of your phone, grab a new one. That's not the problem if it's malicious code, if it's infected. Pay a large amount of dialing sex hotlines or anything else, or open some PDF you get with Bluetooth and dial another sex hotlines without knowing it. But that's only less of money, but you can lose your personal data. That's the problem. You can use your management summaries, your bookkeeping, your financial reports you're storing on your mobile phone. And if it gets stolen, maybe it was stolen by the right guy which can use the things. And about the other thing, the rogue AV, we are not focusing on our tests on zero-day attacks. We are focusing on attacks which are coming to the user, and we do in our testing, we're testing the range of the whole product. This means we are looking is the URL blocked, we're looking is the file downloaded, is it executed, and after it is executed we have to look at the behavior of the program. And on every stage the vendor, the AV product, has the chance to detect, or better say to protect before the threat. So we are looking any kind of stage, and if they're starting a rogue product and the vendor is detecting or protecting before installing, it's okay. But if it's installed and it's calling outside, it's blocked by the firewall only on the outbound, that's too late. It must be blocked or protected before it goes outbound.
In one instance, I have seen that you have this free AV application, and it would detect, it will actually alarm the user. That there are so many issues on your computer, there are like some 15,000.
You mean the fake alarms, or?
Fake alarms. Yeah. And all the user needs to do is say yes to fix it. And the moment yes happens, you have the malware in action. So I'm basically thinking of those kind of
Yeah, we've even seen some that pretends that it's McAfee semantic trend. We don't have the logo of the AV vendor even on there, so that it's hard for the user to distinguish between a legitimate web pop-up, which happened with all your products, right, versus the rogue. Yeah.
And the vendor must detect the rogue too.
Yeah, absolutely.
It's hard.
Yeah.
And we are using all the default. If you are doing the test and there is a question of the product, of the vendor, of the AV product, of the real AV product, we are using the default settings. If there is a malicious filter you want to block and it's by default yes, we're using the yes. If it's by default no, we're using the default no. It depends on the vendor.
So thinking at the life cycle and the purpose of the rogue AV, so why do people have or get rogue AV, and how comes that so much damage is done? So the thing is that rogue AV itself is actually not really damaging. It's a very annoying piece of software, and it can even, let's say, damage the PC. But in fact, the damage is done by the user. So the user gets afraid of those many fake alerts, and then it wants to clean and say, please help me clean it if you are here, something like that. And then, what happens then? It pops up a window where it asks you to buy the software, and the decision to buy, it's up to the user. So giving the credit card number and pressing on I accept the conditions, this is something that an antivirus software cannot really protect of. This is the human decision, and well, I don't know if it's good or bad, but in my perspective, the rogue AV and the damage done through the rogue AV, it's still to the user. This is in order to change this, and I really believe that users are changing the mindset on giving credit cards and buying everything just because Popup say, hey, if you want to clean your system, just buy me. It's like Alice in Wonderland, eat me. That's the point with a rogue AV. Doing
the research we've been seeing, it seems like a twofold or two-pronged approach from the criminals. They're trying to create a lot of false positives, so you end up having sort of this, how do I put this? False positives is the wrong term. They're trying to create a lot of alerts, right? And that's part of the reason why you have so much volume of malware, right? Because the more they can get used to people seeing something going, oh yeah, click OK, click OK, click OK, they become desensitized to it, right? And then it makes it harder for you to protect them. And that's also where the rogue AV comes into play, because it's also sort of undermines the question of, is my existing product working or not working? And there's some interesting research we've been doing in terms of doing some surveys and asking people and seeing just volume on what's going on. But it seems like a very concerted effort to discredit traditional AV products that's going on both by the volume, which I think you mentioned before, as well as some of the rogue AV products. And it's definitely a strategy. I mean, it's not just sort of happening by accident. So.
One more question. Does AMTSO, right?
AMTSO.
Does it recommend any baseline for determining the quality of a sample? Are there any metrics in place for that? So you mentioned that quality of samples is more important.
Yeah, right. So the fundamental principles of AMTSO imply that the sample set is collected and validated, and also it is statistically relevant. So on the AMTSO website, there are a lot of papers with best practices, and also some refer to the sample validation and sample collection. So that those best practices come from researcher areas and also from testers and vendors together. So we work together in order to bring up the best practices from our perspective, since we think that we have the experience to, and we follow that, we have the experience to talk about what would be the best practices.
So I have a little different perspective. Alice knows this. I'm not a fan of AMTSO because of just the thing you just asked a question of, which was, for those of you who couldn't hear, the question was, does AMTSO specifically say, here's how you define a malicious sample, here's the tools you should use, and so on. It doesn't. Which means that AMTSO is, from my perspective, gives the vendors just enough room to say they don't like something. There's no positive reinforcement or a positive model that says, here's exactly what you should do, which to me is just, it's a political out. So I'm not a big fan, and while Alice is representing them, and I like Alice, she's a nice person, I'm not a fan of AMTSO, also because, frankly, it's a vendor organization, primarily, and people who make money from vendors, primarily. There's a couple outside of that, but it's basically, if you're not a vendor, or if you're not making money from a vendor, Peter's probably are you the only exception, Peter? Probably? Yep. Peter's the only exception. Okay, everybody else is making money from the vendors, or it's the vendor themselves. So it's not exactly, their interest is not in well, there's academics who may want to make things better. The marketing people and the business folks know how just to tweak things in the right way so that they can discredit a report if they don't like the results.
I want to leave the opportunity to Alice as an AMTSO member, just to defend yourself.
Every coin has two sides, right? So we were thinking about standards and rules on, but it's pretty hard to come out with a list of what should be used for testing and what not. I mean, it's the organization tries to keep independent, not to influence the testers or the magazine in the way they are going to develop testing methodologies and what kind of tools they are going to use. So I think the only thing we can say, and we have the same opinion, Vic, is that the sample quality, the sample set quality is very important for the results of the test and also the methodology used.
So I think it's up to the independent tester, and every tester should stay independent to accept some standards of AMTSO or to not accept the standards of the AMTSO. It's a decision of the tester. So we select what we can use and we select what we will not use.
Correct me if I'm wrong, but the AMTSO only gives guidelines.
Yeah, only
so
guidelines.
It's up to you how strictly you enforce them, right? Or if you enforce them at all.
Yeah.
So we talked about how the challenge that the web threats pose for the testing, but the second challenge, and Ferenc already alluded to it, was that the products have changed their architecture so that they use themselves the cloud technologies extensively, and that poses a total new challenge for testing them, because now you have to allow them to be updated, and maybe this minute they're updated and next minute they go totally in a different way. So what implications does that have for the testing, and how has that changed your methodologies?
Well, I mean, you just said the products have to be current and up to date at all times. From our perspective, they're on the internet, just like any normal product would be. We tend to test not just consumer products, but enterprise products, which means that the management stations have to be up to date. We have to make sure that they're configured properly so that they're pushing out updates at a certain, whatever the frequency is. One difference between us and Peter's organization is that he uses default settings, but that's primarily because of consumer testing, and we agree with that. that. But on the corporate side, we don't use defaults. We invite the vendors in, and everybody's supposed to tune their own to however they feel is appropriate. And then we test for false positives. Make sure that somebody isn't just saying, block everything because they know it's a test lab, right? So we verify that. So that having this live connectivity and updates and so on poses that challenge. The other challenge is understanding the products a little bit better, because there are some products that build their database over time. There's other products that look specifically at any given URL and get their updates. So if you're building your database over time, one of the challenges is if you're continually rebooting, and we do the same thing Peter does from that perspective, how do you make sure that you have an image with that? How do you know you're starting from a good image that has a fully populated database? So we do things such as having, I'll call it, sort of our baselines images that are not necessarily used, but they're used to we clone those in order to make sure that those are always up to date, and then even as the testing is going on, it gets up to date. But that deals with the issue of if somebody's database grows over time, they're not put at a disadvantage over somebody whose database is all at once or it's per URL. So things like that make it interesting. But at the end of the day, it's just being very meticulous.
So, in my opinion, the very big number of updates is a difficult thing as well, and it is an opportunity as well. So it is an opportunity because it is possible to test more versions, and it can be analyzed, so the evolution of a product can be analyzed as well. And it could be related to not only one version, but a set of versions as well. For example, if we test every version of a product which is released on one day, then after a month we have 30 tested versions, and we can compare the results of them. And we can check and test the evolution of the product as well, and not only for only one product. So I think the big number of new versions and updates are not only a problem but an opportunity as well.
Let me ask another one. Just
specifically for you, because I know that your product works with your testing works with a proxy. How do you distinguish between traffic from the vendor and traffic from the malware? Do you have a way? Do you proxy it and cache it also in the same way? Is there a difference? Because I know that they work differently, but you work specifically with a proxy setup. Is there any difference for you in that traffic, malware traffic, and product traffic?
So it is first. I would like to start it with the beginning. So first, when there is a new URL, then we store it on the proxy. And the first time we don't execute a test against any antivirus, but we execute the malware on a client without any antivirus. We would like to see how it works, but it does. And afterwards, after we have known every activities. For example, it can download other parts from other URLs. We can collect them as well. And when we are ready with this, we can test with antiviruses. And then we know every URLs what the malware use. The others are related to the vendors, but on the other hand, we can know the vendor URLs as well. So we can distinguish with easy firewall rules between the vendor URLs and the malware URLs.
Sorry.
Oh, David, there's a question.
Okay.
I'm sorry if you mentioned that previously, because I was not here from the beginning, but do you have any metrics or how long it takes to update the firms every time that a new sample is detected to the product?
I'm sorry, update.
To update the signatures of your products for validation. Because many times when I was in some malware, we find out in various total, for instance, that it's not being detected and it takes some time obviously to process it and detect the antivirus. So I was wondering if you have any metrics. And the second question related to this one is what do you think of this approach? Because we are seeing that it's very easy for generating a new sample of the same variant as used, for instance. And of course, the signature-based detection is useless in this case because it's very easy to propagate a new sample with a very unique signature. So questions are related.
If you don't mind, I would like Peter to give us a view, and then we start over with the same question with Vic, so that we can hear the whole table. Peter and the view of the AMTSO member. Okay.
We do it in a very honest way. Every day in the morning, we do a totally update of all scanners, a complete update, and for each test run, let me show have it in where. Yeah. Every morning we do totally update, download and install a new base of the image of the complete test lab, which is a totally updated antivirus scanner. And for each test case, for the testing cycle, for each malicious URL, we do a total update of the scanner, which signature-based updates or anything else. We give the product about 2 minutes to do the update. And this is enough. If the product does not an update by its own, we force it with a batch job. So for each test case, the signatures are not older than 2 or 3 minutes. They're always totally up to date. This is very important because the user, which should be protected, has the same. It's an updated antivirus product. Some products give you updates once a day. Some products give you updates every 8 minutes, and some products are using cloud-based methodology or a combination of all. So we have really the newest version of the antivirus and the newest versions of the signatures.
Yes, but we're able to generate a new signature in the very same day that the sample is detected?
No, we don't need to. We have an updated antivirus scanner, and it's the same update as the user has.
So Peter, I think he's.
Is it a misunderstanding because of my English?
I think he's asking a different question, which is, are you measuring how long it takes? Yes, how long it takes the vendors to block something?
Yeah.
We do not measure this. This is up to Rick.
Just to add before it goes to Vic, the concept of protection, so it is reflected and introduced in some products, so that in case of Trend Micro, we are more looking of protecting the users from the source itself, so that we are actually trying to and working hard to block the threat by its source and not the threat by itself. So the era of signatures, so it's not the main purpose of a protection, because updating signatures of files might not, so it's less effective than blocking the source of the malware, like an URL or domain.
Yeah, but in this case, for instance, if we are used, how can it be possible that one sample is not detected, but tomorrow it's been detected? But it's the same seals, it's doing exactly the same. So it's not that the heuristic needs to update the behavior or something, because the sample is doing exactly the same, but the sample itself is changing the identifier, the hashes, and everything. So in this case, I assume that it is some kind of signature detective thing like here.
Right. Alice, let me rephrase it because I think I understand the question, and I would like to know the recommendation of the AMTSO. What he wants to know is, we not only want to measure whether we detect the sample or not, but when we finally detect the sample. So do we keep monitoring with the same pattern file or with newer pattern files and seeing, okay, now we didn't detect it, but 10 hours later we finally detected it. So does that metric exist? Vic confirmed that they do measure that. Peter, they don't measure that, but is there any recommendation for the AMTSO as to whether we should or how?
No, actually the AMTSO does not make any statements about this. I mean, it's matter of vendors, how they design the protection, and it's up to the testers how they test these metrics.
Okay, that's fair enough. Vic wants to add something to it. Am I right with your question? Did I rephrase it correctly? Okay.
So, whereas AMTSO may not take a perspective on this, we do, which is that when Alice started talking about from a trend perspective, there's a few vendors, Trend Micro is one of them, McAfee is one of them, there's others, who are blocking the URL. So they know, let's say, that a certain URL and certain variants of that URL have been dishing out malware. There's maybe one small recorded usage for valid purposes, or maybe no valid purposes. If you know that, then whether or not it's Zeus A, B, C, D, it doesn't matter. You can block the URL. Now, in the case of something like Zeus, it started off as traditional malware and moved into the web-based with an exploit and so on. The benefit of a URL system is it doesn't necessarily care whether or not it's malware or whether it's an exploit or whether it's a phish. Just from a reputation perspective, it's a known bad. Now, that doesn't mean that you're going to stop Zeus. It just means that that source, as Alice was describing, is a known bad. But what we've seen is in our testing, there's about a 17% increase in blocking malware, right, of all kinds, with those types of reputation systems. And it's different for different vendors, but it's a pretty big uplift versus just the traditional signature-based malware detection.
I have it very clear that you guys, your positions, but I didn't hear Ferenc about this. I would like to hear whether your testing tests the quality of pattern file over time. So not whether we detect it now, but when do we finally detect it?
Just a yes or no, or
something. So this is the live web page from our testing, and it is. I have mentioned it earlier that it is now in the testing phase, so it is not available publicly on the net. So as you can see, that yellow text represents updates, and all of updates are executed between 10 or 15 minutes. And as Peter said that they execute every update once a day, then we execute updates continuously, and we would like to save all of versions if it is possible. Of course, if there is an anti-malware where there is a new update in 2 minutes or 3 minutes, we are unable to save that. Our purpose is to store each version if they are released in about 20 minutes. And later we can check these updates. And reflecting to the question that if there is a URL and there is an anti-malware which can detect that URL.
How long does it take? Meaning, you test it now and then 6 hours from now or 8 hours from now and then again and again and again until it catches it.
So all framework is able to store the URL content, and we can check the anti-malware product against this URL, and later we can check again and again, and we can determine which is the first version which can detect it. And on the other hand, if the first version we check can detect that URL, for example, we receive the URL later and then anti-malware product has updated against this, then we can go back as well. So if it is required, we can determine which was the first version which could detect it.
So I wanted to add one thing, which is that the question that you asked about how long it takes, so we measure every 6 hours, but what we do is we don't actually validate the samples before we test. Validate after we test. We collect everything because it's impossible to test 0 hour if you validate first, right? So we'll validate as we go, but generally speaking, at the tail end of a test, let's say a 10-day test, we'll spend 3, 4, 5 days going through deep validation, executing, see what they're doing, the whole 9 yards, right? Not just the sandboxes and things like that, but that we use in the early stage to prune the stuff that is obviously no good. So now, I mean, that's, I think, one difference between us and Peter. You don't focus on the zero.
No, we don't focus on the 0 days, yeah. So it's not so important. But we do an update of the antivirus product before each test case. So we have always the newest versions. Right.
Yeah, so we tend to focus more on the 0 hour stuff.
Yeah, but when you say that you are focusing on 0 days, what do you mean by 0 days? Because, for instance, there are 0 days that last for months or years.
This is
saying that it's not that important. I'm not so sure.
Well, a 0 day is for me a 0 day which we have researched now, and a 0 day is a really 0 day. This is coming up on Monday and we test on Monday. That's a 0 day for us. If it's older than 3 or 4 days, we test it. That's not a 0 day for us. Yeah.
It's that it lasts more.
Yeah.
Until the vendor releases the patch or something like that. Yes.
No, it's just as
talking about exploits and vulnerabilities. Yeah. Okay, so that's a little bit. I don't think, Peter, you don't test exploits at all, right?
We're testing exploits.
So you are doing exploits, not just malware.
Yeah.
Okay, because we've been testing exploits as well, but we're not testing 0 day exploits. Okay, now that's something that's going to change. Part of our research, we've developed a tool that allows us to just see whatever's out there from an exploit perspective, but it's literally multiple man years to develop the tool to see and find the exploits. Now, most of the exploits we find are 3, 4, 5 years old. They're still being used and they're part of most major attacks. Something like what happened with the Google, you're talking about Aurora, type of an exploit is very rare. And it happens, but in terms of, it gets a lot of media coverage, but it's the tip of the iceberg. It's probably 5 or 6%, if that. I mean, the other 95% is IE peers, it's things like that have been around for a little while. So in some cases, I mean, and we actually have an exploit report that came out recently that vendors were still missing exploits that had been, or vulnerabilities that had been disclosed in 2006, 2007. Vendors were still missing protecting against those exploits. So we differentiate malware from exploits and vulnerabilities. I mean, not everybody does, but we think there's a clear distinction between a consensual download where somebody intentionally clicks on something and downloads it thinking that it's bad. So we call it social engineering. Versus an exploit, which is it's an attack on the computer, and it's not an attack on the person, right? And now the AV industry calls them drive-bys, but frankly, there's a lot of exploits that don't drop off malware onto the disk that we've been seeing. About 30% of what we've been seeing is keyloggers and Trojans that are just memory resident, which frankly, I can honestly say 0% of the antivirus vendors catch it, unless they stop the exploit. Right? I mean, it's just because the folks that are just focusing on the malware, they tend to need it to touch disk before they can do anything with it. So we can have a longer discussion. I mean, but if you actually open panel, you can have more questions. But
so I just wanted to clarify, when they were talking about 0 days, it's 0 days on a regular sample from the day that the sample has been first seen. We never talked about exploit until just a second ago. There's a distinction there. Okay, and I'd like to ask now the panelists about the implications of how malware samples are being presented to products. Because back in the day, we just fire up a scan like Ferenc was telling us. You do scan.exe ****, that's it. You have just a database or a folder full of malware. You just let it run and let's see what the results are. Nowadays, how you present those URLs, how you present those files is in a different way. Does that change? Does that affect how the performance or the metrics of the products are, how the testing are being done, etc.?
Yes.
Short answer.
So we actually have some reports coming out that show exact same time frame, different results when a product was tested with the same sample coming over USB, coming over network file share, coming through email, coming by web. Different results. It was really, really interesting. And everybody's told us the same thing. It's the same engine. Well, anybody who's done software development knows it's not just the engine, it's the implementation of the engine that matters. And so we had folks that would catch, let's say, 75% on download from the web, catching 50% when it was coming through Outlook, or catching 80% when it was coming over network file share. But if you double-click on the executable on the network file share, they got 0%. It was really interesting. So the usage and the use cases that you're testing are really important, and from my perspective, you have to document it, because different methods have very, very different results.
Of course, I have a very short answer for this. We just introduced the malware, the URLs or the files, as the same way as the user will get it. And it must be the same way. It's exactly what Rick said. You have to introduce it in the same way. Short, but that's it.
I am agree with that.
Yeah, I think that it's really very important to describe the metrics in the report so that the users and the readers have the chance to make the distinction and to identify which products suit best to its environment.
So about the sample collection, how sample collection has evolved. You were kind of skimming through the topic earlier, but I would like to get a little bit deeper onto how do you validate samples, how do you get those samples. In the case of URLs, how are those samples gathered, where do we get them from?
Well, sort of like what Peter was describing, the way you test is in the way that the user is using the product, the same way you have to source your malware or source your samples. Right. So let's say, for example, it's coming through email. Then if it's an attachment on email, you can't use it, put it on a web server and say it's a web attachment. It doesn't work. I mean, it's not fair, it's not right. Similarly, if there's a click-through on an email that goes to a website, right, and you have to make sure that that URL is what you're collecting, including the reference IDs, anything like that, because referrals and things like that, as mentioned multiple times, count. Because if you just go to a URL without the appropriate referral, you're not necessarily going to get the malware. You may get some pretty page, right? So, it's very important that and we actually have folks harvesting Facebook, harvesting MySpace, harvesting Twitter, harvesting all these live social networking sites, because that again is how people get them, right? So it is very difficult, frankly, I'm sure that I haven't actually talked to any of the vendors about how they're harvesting from those sources, but it's difficult unless you actually have people interacting.
So do they go undercover?
Oh yeah, we have people that have fake IDs, like fake identities, and they're pictures of their dogs and cats, and this is what I did today, and yeah, make friends. Yeah. I mean, you have to do that.
Yeah, I think it's a very good approach to try to replicate the reality, the landscape, in order to get what the user might get. Because, well, for 5 million samples of unique threats, what would be the criteria you take or you use in order to select what to test?
Yeah. In this case, we as testers, which have a very limited financial background, have to do the same work as the vendors are doing, and they have billions of dollars. We have a very smaller amount, and we have to do the same work in researching URLs or samples. What we are focusing on AVComparatives, we are not using any URLs which are submitted by vendors. We are using only our in-house crawlers and our in-house research teams, and we are not using any URLs from vendors or from any official sources like Malware domain list or anything else. We avoid this.
So, in my opinion, I think there are two main problems about samples. The first is the sample selection, the other is the validation. As Peter said, that they don't use any URLs from vendors, but in this case there could be a problem that I think now in the antivirus world, only antivirus vendors can collect information about the prevalence of malware. And it is a very good question then that how could we select relevant samples from a very big number of URLs, and which is more important, and maybe the others are not so more important. In our way, as I mentioned, we can use two possibilities. The first is about validating, validate every sample we use for testing. This is easy because we have a special frame system and we can check every sample, and it is possible if we would like to execute on-demand or on-access scanning, but not dynamic testing. In the case of dynamic testing, validation should be executed during the test as well. So I think if we test anti-malware programs against malware, it can be a file in a file, or it can be a URL, then we test it dynamically, so we execute the malicious code, then we have to prove that the malicious code is activated.
We take a bit of a different approach, just because our belief is that if we get the samples from vendors, and I think Peter's the same way, the vendor's only going to give you the things that they know they're going to catch, right? I mean, no vendor is going to say, here's stuff that I'm not going to catch. So there's that problem with that, and then the second problem is that if you're limiting yourself to those samples, and there may be entire categories and types of threats that products are not, as a whole, the industry may not be addressing, because everybody's sort of circling the same samples around, and it's not just, I mean, there's, not just the testers, the vendors who also circulate the same samples, right? So anything outside of that box gets missed, and that's a formula for being sort of kicked upside the head by the criminals, which has sort of happened a few times. Right, whereas if everybody's independently doing their research, then the chances of somebody coming across something, whether it's testers or vendors, right, is a lot greater than if everybody's sort of collaborating and cooperating. I'm just in general, I understand the issue that when you're talking about this 50,000 samples a day, that you want to have some sort of cooperation. I'm not sure that's a good idea, because I think that I think it can breed complacency, and everybody says, oh, yeah, you saw it, I saw it, everybody else saw it, and you think that the universe is what's defined by the things that everybody sees in common, and nobody's looking for things that are outside of that known universe. I don't know if that makes sense or not, but that's one of the things just systemically I'm not a believer in sharing samples. I mean, and that probably goes against what most AV guys think, but probably fairly controversial to those guys, but...
Any other view on this?
So I'd like to ask if there's no more questions. Okay, fine.
Just one question. I think most of the conversation is focused around Windows-based viruses. Haven't seen any metrics to indicate there hasn't been any increase or what sort of rate of increase is there in malware aimed at non-Windows platforms such as Mac, Linux, etc. And I'm sure the manager will say yes, this is increasing that and therefore you have a product on the platform. I'm sure people using Mac and Linux start worrying about viruses.
We already talked a bit about Android viruses, but that's a great question. Mac and Linux, do you guys focus on it at all? A little bit?
We've done some research. We're not seeing anything with Macs. I mean, the same as there was 3 years ago, which is virtually zero, statistically zero. From a Linux perspective, we're seeing an uptick. And I think it's probably tied to the fact that Android's a Linux operating system at the end of the day. And so a lot of the same attacks that are being used or that are being used in sort of proof of concept right now are being tried out by the bad guys. They can also hit a number of different Linux systems. But I think it's still very early to say if there's a trend.
Yeah, it's the same way. So we don't see a trend on Macs, but it's no difference which operating system you're using against phishing. Yeah, you need a browser. It doesn't depend on the operating system. Phishing is everywhere.
Yeah, so actually, as we said before, the threat delivery nowadays is through web, so that actually it makes no difference what you are using. If the threat is going to be executed and posted in a memory and spy your credit card numbers or your intelligence property, then yeah, you'll get it.
But what Brian is saying is that we not only focus on the URL, but the URL will bring an exe, and that exe is very platform dependent.
The exe itself.
Is there any guideline as for testing on Linux or whatever kind of other executable, not only exes?
Yeah.
That was the real question, because URLs we understand. If it's phishing, if it's a URL that downloads something, we can block the URL. But after that, the attack focuses on an exe that finally has to be run and executed on a specific platform.
Yeah, from executable applications, I think indeed Macintosh systems are more secure due to their concept, due to their design. In case of Linux, I would say that Linux systems, since those are pretty used in the server landscape, that those are more attacked by remote access and especially by rootkits. And of course, these are the main types of threats which the vendors try to detect and to block.
So I want to add one thing, which is that there's a lot of these toolkits, exploit toolkits that are out there, right, that folks are purchasing and then use to dish up some sort of nasty. What a lot of them do is they fingerprint what the operating system and the applications that are running are. So it can tell if you're running, just like when you go to, let's say, a website, bbc.co.uk, it can tell if you're running Internet Explorer or Firefox, and it can, depending on what you're running, it can provide you the optimal website experience, right? Same thing goes for the malware, right? So now what we're seeing is that, what I'm seeing, we're seeing in our lab is that if you're running a Mac, you just don't see a lot of it. I mean, there's still some, but generally speaking, if it's a PE, it's an executable, it's a Windows-based target, right? Because that's still the majority of the systems that are running out there on people's desktops. Now, exploits, if it's an exploit against Adobe Acrobat or an exploit against Firefox, you're absolutely right. It doesn't matter what platform it is. It's the, now, are the offsets potentially different? Are the, I don't know how much you know about exploits, but basically you can have the same vulnerability, but because it's on a different operating system, you can have different offsets to trigger the vulnerability, right, and exploit the system. So you can be different, but again, if you're fingerprinting what it is, then it doesn't matter. But again, just in terms of the effort people are making, I mean, at the end of the day, they have an ROI like anybody else in business, and the ROI is just not there in a lot of cases. I'm not sure that Mac is necessarily more secure from exploits. From traditional malware, yes, because you have to sign in, give your password, you want to run something, right? But if a system is being exploited by its very nature, it's bypassing those security functions. So, and I'm not sure, just the research we've done, I'm not sure that Mac is all that secure, frankly. It's just not that widely used.
Yeah, I find it, those few points, if I was to target somebody, like the other Macs, to me would be prime target today, because the people who will buy the Macs tend to be more happy than people who buy the volumes. And there is the attitude of, because I don't think any virus, so there are more protected.
Well, frankly, even if you had AV, if it's an exploit, I don't think it would catch it. I mean, most of our testing has shown that, at least on the consumer side, now the corporate side it's different, but on the consumer side, not so hot.
So we only have a few minutes left, so I'd like to wrap up, or let you guys wrap it up, by telling us how performance metrics have changed, because they clearly have evolved a lot. We have included new metrics like the ones we were talking about earlier about the retest, but I'm sure that there are many new metrics that didn't exist before and now we're telling people about. And well, I would like you to expound on that topic, and perhaps, Peter, you were asking me earlier about showing your test. Maybe that would be a great moment to show your metrics. So let's start with Vic. Let's go all the way to you, and then you show us your screens, okay?
So from a performance perspective, I'm assuming you're talking about like the boot time and things like that?
Everything.
Okay.
All the performance.
So we actually have some reports coming out. The testing has been done a long time now, that measure how long it takes to open an application with a baseline, meaning there's no AV product, and then install the AV product. How long does it take to do it? And we measure, usually it's 500 iterations, so we can average out and say, took longer one time versus another time. It doesn't have a meaningful difference. It's sort of that chart that Peter was showing earlier in terms of, how many iterations or how large your sample size affects affects your error rate, in fact. So that's one of the things, if you're testing performance, if you just do it one time or 10 times, your error rate's going to be very high. So we test boot time, we test how long does it take to load an application. We were actually testing certain things in the past, like looking at how much memory there was being used and so on, but in talking to our enterprise customers, they didn't care. They said just, we care about how long it takes to boot. We care about, and less than that, because booting only happens once a week. We care about, how long it takes to open up a certain application. So it's warm start, load time, things like that matter. So for the app, Word, Acrobat, Excel, things that people use every day.
Not only that, I meant also the performance of the protection, the performance of the AV product. It used to be like we detect 97%.
Oh, okay.
Now there's more metrics on that. How do you measure the performance of that protection?
Okay, so we measure in different discrete areas. We measure the performance of the web attack, as Peter, he's got the same thing here, right? We measure how long it takes time to block and so on as part of that. We also measure separately exploit protection. We measure separately the ability of handling evasions properly, which for everybody across the board was not very good. And we measure network file share, USB, email, and so on. So basically all the different ways that a person's going to be using a product. And so it's got a lot more complicated compared to just you can right click and scan something. It means that I've got to test something 17 different ways from Sunday in order to give people accurate advice. But that's what we have to do.
Right. So, about a year ago, we have made a little survey about which is the most important property of anti-malware products. So on the first, there is of course the knowledge that how many malwares are known by the anti-malware, and on the second place,